Hey everyone, in this video we'll be going over the DHT11 humidity and temperature sensor. We'll be covering the sensor specs, we'll also be talking about sensor pins, we'll be talking about how to connect it to an Arduino UNO, we'll be covering the Arduino programming, and of course we'll be going over some testing and examples. So let's get started. This sensor is, as the name implies, mainly used for measuring humidity and temperature. Specifically, it measures relative humidity. So the supply voltage is a minimum of 3 volts and a maximum of 5.5 volts. And the sensor can measure anywhere between 0 Celsius and 50 Celsius, or basically between 32 Fahrenheit and 122 Fahrenheit. From a relative humidity, the range depends on the temperature, but roughly it'll go anywhere between 20% and 90%. So when it's at 0 Celsius or 32 Fahrenheit, it will be between 30 and 90% relative humidity. When you're at 25 Celsius or 77 Fahrenheit, it will be between 20 and 90%. And at the upper range of 50 Celsius, it will be between 20% and 80%. The accuracy of the sensor is on the temperature is plus or minus 2 Celsius or plus or minus 3.6 Fahrenheit. If you watch my previous video on the DS18B20, you will realize that from a temperature measurement, this sensor is much less accurate versus the DS18B20, which had a accuracy and temperature of plus or minus 0.5 Celsius or 0.9 Fahrenheit. So much less accurate, but it does come with the added benefit of being able to measure relative humidity. If you're working on something more critical, you could potentially even use both sensors. This one, the DHT11, and the other one, the DS18B20. If you need some help picturing this accuracy, you can see in the image below that we have that range of going, if we took a measurement of 20 Celsius, the actual true temperature could be anywhere between 18 or 22. That's where you get your plus or minus 2. So 20 minus 2 will be 18, plus 2, 22. And then you can do the same thing for the Fahrenheit. Now the pins on the sensor are pretty straightforward, only 3. So you'll have VCC, where you would apply relative to ground either the 3 volts or the 5.5 or anything in between. The ground obviously goes to ground, and it should connect to the same ground as your microcontroller, say an Arduino. And then your output will provide the signal of the sensor measurement. Now, from the previous pins that we just looked at, you can see how then you go ahead and proceed to wire them. In this case, I'll show an Arduino UNO. So you proceed to wire your ground here on the sensor to the ground of the Arduino UNO. The VCC goes to, in this case, I'm putting it to the 5 volts. Arguably, you could also use the 3.3. I'm using 5. And then your signal, we're connecting to the digital input number 2 in the Arduino UNO. So let's keep going. Now, before we move into the Arduino code, we will first need to download the appropriate library, which we'll do so from GitHub. So, I'll go ahead and leave a link in the description so you can access the same library that we're looking at right now. We'll go ahead and click code, download a zip. And once we're done downloading, we'll go ahead and import into Arduino. Now, once we have Arduino open, let's go ahead and import the library. For this, we go to Sketch, Include Library, and then you can click on Add Zip Library. Click. Once you click, go to the appropriate library, select it, and click Open. You will see that the library will be added. Now, that library actually comes with the code you need for this example. So go ahead and open that library. Now, I have this library. When I downloaded it, it went to my PC and then downloads. So I'll go ahead, open the library, drill down to examples. And there you can see there DHT11 default. You can copy that folder and you can just place it in whatever folder you're working for this example or project. If you double click, you'll see it'll have the Arduino code in it. That's the one you want to work with. But instead of messing with the library, just copy that file and place it wherever you need to. So I went ahead and opened that example, and you can see here we have the Arduino code. One thing I will change is this to 9600. So that is the serial channel that I've been using. And we can just click run. Click run. Compile the sketch. Wait a little bit. Now that it's done uploading, we open the serial monitor. We should see how the temperature, in this case, they're listing it as 23 Celsius, and then a 24% relative humidity is being displayed. So I'm going to change this a little bit because I would like to see it a little bit differently. So let's do that. So one thing I would like to see would be an RH for relative humidity. Would also like to see a percent next to it. And then here, instead of this asterisk, I would like to see D for degree C. Let's also delete this. And now we can see the output with different formatting than before. And if you would like to go ahead and get that in Fahrenheit, we could also do the following. So to add Fahrenheit, I will go ahead and add a new line. I'll simply go ahead and copy and paste this line, paste it right there, change the C to an F. I'll remove this comma so it doesn't look odd, and simply add a backslash with a space. And to go from Celsius to Fahrenheit, all we do multiply times 1.8, add 32, and we should be good to go. So now let's go ahead and upload the code, and let's check it out. So we see 23 degrees Celsius or 73.4 degrees Fahrenheit at 23% relative humidity. Now let's do some testing. First, we'll set the DHT11 sensor next to our thermostat to see that both are reading 73 degrees Fahrenheit. Next, we'll go ahead and set up a pot of boiling water. We'll set up a fan to blow some of that steam towards the sensor, and now we'll check out the relative humidity. As we blow it, we can see that it starts to kind of climb up. We're at 79%, now 80, 83, 87%, and so on. Now, when taking all these readings and measurements, just take into account the sensor accuracy as talked before. So for temperature is plus or minus 2 Celsius or plus or minus 3.6 Fahrenheit, and for relative humidity is plus or minus 5%. So this concludes this video. I really hope you found it helpful. If you did, please give us a thumbs up and subscribe. Thank you very much. See you in the next one.